In this video, we're going to talk about how to solve quadratic inequalities by graphing in Desmos. So I just want to remind you about this chart that tells us how we can look at the inequality sign in an original problem and then figure out how we're going to represent our solution as a graph, as an inequality, and as an interval. So remember, the inequality sign is going to help you determine how to write the solution and also whether the endpoints are included. So here's how we're going to solve quadratic inequalities by graphing. We're going to type each side of the inequality into a separate row in Desmos, identify the intersection points, and then use the inequality sign to determine whether the endpoints are included. Then we're going to determine what values of x make the inequality true, and we can write the solution as an inequality graph or interval. So let's start off with this example. Here we have x squared plus 3x minus 10 is less than or equal to 0. So what I'm going to do is I'm going to start off by going ahead and graphing this in Desmos. So this parabola on the left side that's represented by this quadratic is going to go into row 1. And this right side I'm going to represent as a line. And the way I'm going to do this is I'm going to say y equals x squared plus 3x minus 10 in row 1. And then in row 2, I'm going to write y equals 0. Okay, so let's go ahead and go to Desmos and do that. So we have y equals x squared plus 3x minus 10. And then in row 2, I'm going to type y equals 0. Okay, so now you can see I have the graphs represented here. And then what I'm going to do is identify the intersection points. So remember, I can do that by just clicking on them in Desmos. And what I'm looking for here is the x values. Okay, so it's very important to notice the x coordinates of these points because what I'm looking for is the values of x. Let's think about how we're going to represent the solution. So here we have this parabola, x squared plus 3x minus 10 is less than or equal to 0. Okay, so we're going to look for places where the parabola is below the line. Okay, so you can see that occurs here in this section between -5 and 2. So now it's a question of how do we represent this solution? Well, remember the inequality sign that less than or equal to is going to be our deciding factor in how we represent our solution. So I've highlighted the row in the chart that's going to tell me how to write this solution. So if I'm going to represent it on the number line, I'm going to put endpoints at -5 and 2. And I'm going to put filled in circles at those endpoints, and then I'm going to shade the region in between the two endpoints. If I'm going to write this as an inequality, I'm going to write -5 less than or equal to x less than or equal to 2. And as an interval, I'm going to put square brackets around these endpoints because the endpoints are included. So now you can go ahead and pause the video and try doing this example on your own. So here's how you'd go about solving this problem. So what I did is I first entered this into Desmos. So I put the left-hand side as y equals x squared minus 5x minus 6, and the right side as y equals 0. When I go to my graph in Desmos, I can see I have my two intersection points when I click on them. So you can see I have an intersection point at -1 and at x equals 6. So those are going to be my two endpoints. So now it's a question of how do I write my solution? Well, this inequality is asking us where is the parabola greater than the line? Okay, so where on this graph do you see the parabola sitting above the line? Well, you see the parabola is here in green. Okay, so I can see this section from -1 to -infinity, that parabola is above the line. And then from this section where I go from 6 to +infinity, the parabola is above that purple line. So I'm going to look for those two pieces and think about how I can represent them. Well, I'm going to use that inequality symbol as my guide, right? So if it's a greater than, that means the endpoints are not included, and I'm going to shade away from those endpoints, right? We shade on the outside. So this is what the solution looks like as a graph. If I'm writing it as an inequality, it's going to be an or inequality. So x is less than -1 or x is greater than 6. If I write it as an interval, remember I need to write it in two pieces. So -infinity to -1 or 6 to infinity. Okay, so keep in mind that we have to use those open parentheses everywhere because those endpoints are not included. So now let's try this example. So here we have x squared is greater than 49. So what we're going to do is we're going to go ahead and put both pieces of this inequality into Desmos. So I have y equals x squared, and I have y equals 49. Okay, so I'm going to have to do a little bit of scrolling to find my intersection points because it's all the way up at 49. When I click on those points, I can see them in Desmos. So let's think about what this inequality is asking us. It's saying, where's the parabola above the line? Okay, so the parabola is in black. You can see it's above the line for this section from -7 to -infinity. And it's also above the line for this section from 7 to +infinity. Okay, so now let's use this chart to help us figure out how to write the solution. So when I have a greater than sign, my endpoints are not going to be included. So I'm going to go ahead and write this on a graph. My endpoints are at -7 and +7. So I'm going to put open circles there. And remember, I have to shade on the outside. Okay, because there's two pieces where this inequality is true. If I write this as inequalities, I'm going to write this as x is less than -7 or x is greater than 7. If I write this as an interval, I'm going to say -infinity to -7 or 7 to infinity. So now you can go ahead and pause the video and try doing this example on your own. So here I'm looking for places where my parabola is less than or equal to the line, okay? So I want to find where on my graph the parabola is below the line. And you can see that's right here in this region from -10 to +2. So now let's use the chart to help us figure out how to write the solution. Since it's a less than or equal to, my endpoints will be included. So on a graph, I'm going to put endpoints at -10 and 2 with filled in circles, and I'm going to shade the region between those two endpoints. As an interval, I'd put square brackets and say it goes from -10 to 2. And as an inequality, I write it as an and inequality, -10 less than or equal to x less than or equal to 2. So you can solve quadratic inequalities by graphing each side of the inequality in Desmos and looking for the intersection points. Use the inequality sign to determine whether the endpoints are included, and then write the solution set for the values that make the original inequality true.